Yes, hello guys, good morning, good afternoon, good evening, depending on where you are. My name is CPA Makan. Today I'm taking you through the topic on matrices and specifically the application of matrices. We have already done the introduction of matrices, whereby we defined the meaning of the word matrices. We also went ahead and identified specific types of matrices that have actually helped us to do some computation in the second video in relation to the matrices, whereby we were able to define the meaning of the word identity matrices. We're able to know what is transpose matrices and also sub matrices. So these three types of matrices are very important when it comes to calculation or computation of matrices. Today is just an application of matrices. So if you want to know more and more about the matrices, go back to my introduction on matrices. Then after the introduction, go to the computation on matrices before you join today's lesson on application of matrices, which is input-output analysis. Correct? Input-output analysis. Now, when you talk about input-output analysis, it's also called input-output model. When you go to other books, it is also called Leontief input-output analysis. So when you talk about input-output analysis, you are also talking about Leontief model. In this case, this is a scenario where we are trying to understand how the data is analyzed in terms of interdependence. That yes, we have some of the industries or sections or sectors or economies economies whereby these particular industries or a sector interact and they are interrelated in terms of production or in terms of the output. In this case now, we are going to see what is this model all about. This particular model is all about the input. And when you talk about an input, you might be referring to either raw materials. Correct? That these raw materials here undergo a special process called processing. Once this processing has taken place, we have now what we call the output. Correct? So this output here is also referred to results. That if you want to obtain the final result, you need to have an input. An input is therefore raw material which undergo a particular process to give us an output. And that is what we call output. Now when you talk about the input, output, we are referring to a process where the raw materials in one sector, for example, we can have raw materials from agricultural sector. These raw materials from agricultural sector will act as an input in the industry. Correct? This industry here will produce now what they call a final output. So therefore, input-output analysis is a model used to show the interrelationship. It used mainly to show the interdependence of sectors or industries. Yes, it means that one industry does not stand on its own. It depends on other industries for it to produce. For example, if you are in agricultural sector, you produce the raw materials as output. These raw materials as output can be used as input in the industry. Or it can also be used as a final product to be consumed as it is. So therefore, we have some of the industries that will consume this output that we are produced from the farms. or it can also be used directly by the consumer. So therefore, when you are trying to analyze the input and the output, that is what they call the input-output what? Analysis. And in this case, it only happens when we have specific industries that are interrelated or interdependent. Now, in this case, we have now two types of industries. We have two types of industries in this case. One, we have what we call closed input-output model. And we have a closed, and then we have open input-output model. Now, when you are referring to the closed input-output model, we are referring to an interdependence where when these products have been produced out, they are automatically consumed by the internal sectors or internal what? Industries that are interrelated. So which means there is no any product that is left out to be consumed by external. So if all the output is consumed by the interrelated industries or sectors, that type of input-output model is what they call what? Closed input model. Now, there is another model called output-input model. This particular type of a model is open, that whatever has been produced by the interdependent sectors or industries, they can also be sold to external, correct? Industries that are not related with the industries in this particular cycle. So that type of input-output is called what? Open input-output what? Model. And therefore, in this case, it tells us that when you talk about the total output, correct? You are talking about we are talking about intermediate output. You add intermediate output, we add the final output. When you talk about intermediate output, we are referring to that particular output that is mainly consumed by the interrelated industries or sectors. And the amount that we also sell to outsiders, we are calling it final output, or we can also say external. We can use the word external to demonstrate the same. So therefore, in this particular case, we are going to see how to determine the total output. And we are going to say the total output is given by intermediate output plus the final output. And in simples, we can say X in simples you can say total X is given by 1, another X times that plus D. I want to demonstrate what it means. D here refers to the final output or a final consumer. This is the amount of output that can be consumed by external. And A here is the matrix. This matrix here is what is referred to as Leontief matrix, of which we are going to see how it is calculated. Then this Leontief matrix here is multiplied by the total output. So therefore, for us to get the total output, it will be the internal output or intermediate output plus external what? Output. So let's now make X the subject of the formula. X equals to XA plus D, whereby we have said X is the total number of output, which is in the intermediate output plus the final output, then plus what? Final output, which is external in this case. Now make x the subject of the formula. In this case now, we bring this side. It will be now x minus xa equals to d. Then x outside 1 minus a equals to d. You divide both sides by 1 minus a. Then you divide this by 1 minus a. Then you cancel. Your x is given by demand, final demand, that's external demand, over 1 minus a. And we can also write this in the inverse form by saying this 1 minus a can be power negative n. So therefore it can also be written as 1 minus a power negative 1. Then you are multiplying with what? D. Therefore it means that for us to calculate the total output, it should be 1 minus a, you then inverse times what? D. I want to interpret it carefully. This one you are seeing here is what we were talking about from the introduction as identity matrix. Identity matrix. Identity matrix. Correct? So when you see I, this one is like 1, but it is not really that 1, but it is identity matrix. And this A here is the Leontief matrix. Another word for Leontief matrix is what we call coefficient. Coefficient of matrix. And the coefficient of matrix refers to the proportion of the output consumed internally and the proportion of output that is left to outsiders. We are going to see how to calculate this coefficient of matrix. A person who came up with this formula that I've just arrived at here by saying the total output is 1 minus a into brackets power negative n plus d is what we call W Leontief. And this Leontief, that is why in most of the questions, examiner is asking you, calculate the Leontief matrix. If they are saying calculate Leontief matrix, they are referring to coefficient of matrix. Sometimes it's also called input output matrix. So class, if you don't have knowledge about the previous video on matrices, kindly go back to our video, watch the introduction, come to the computation of matrices before you come and look at this topic called what? Input-output analysis, which is an application of matrices. So let's now go to our today's work. Today I have some few questions from input-output analysis. And I'm still insisting it is very important for us to note that for you to do this, you must be in a position, correct? You must be in a position to know how to calculate three things. One, you must be in a position to calculate three things. One, you must be in a position to interpret the entire question in the matrix. Two, we said for us to calculate the matrix, there are procedures to be followed. Procedure number one is to develop what they call coefficient factor template. I hope you still remember the template. Whereby we are saying this template is in the form of plus, minus, plus, minus, plus, minus, plus, minus, plus. So this one here, when it is what? 3 by 3 matrix. If it is 2 by 2 matrix, plus, minus, plus, minus. This is a template I'm referring to. Go back to our previous video. Once you have determined the template, the second step is to calculate what we call what? The template. Once you have done the template, you calculate what we call coefficient matrices. Matrices is now expansion, developing or coming up with the matrices from the template that you have developed. Then after you have done that, determine what they call determinant. Then the third one is the inverse. Then the fifth one is just now the results, which if it is x, calculate the value of x. So I hope and believe that you still remember this particular part. So let's go to the question that I have them. So before you watch the video, ensure that you have downloaded the questions that will be attached to the video. Okay, download the questions, then from there watch the video as you check the questions. Now question 1. Question 1. The following is the input-output table for 3 industries. Yes, for 3 industries. So we have X1, X2, X3. We have F here. Then we have the total output. We have X1, X2, X3. So we have 8 here, we have 8 here, we have 8 here, 10, 20, 10, 10, 6, 10. We have 4, 6, 2. Finally, we have 32, 40, 30. So we have this one. So that is the table on input-output analysis. Question 1. Determine the technology matrix. So determine the technological matrix. It's the same as the technical coefficient matrix, and it's the same as input-output matrix, and it's the same as Leontief matrix. So your work is very simple. Now, Roman 1. Determine what? Technical coefficient matrix. Correct? Now, it is very simple. Look at what I'm going to do. That for you to produce 1 unit of X1, you need 8 units of X1, 8 units of X2, and 8 units of X3 to produce only 1 finished product for X1. For X2, 1 unit only, you need 10 units of X1, 20 units of X2, 10 units of X3. 1 unit of X3, you need 10 units of X1, 6 units of X2, and 6 units of X3. Now, the 4 you are seeing here, this is what is sold to the external. This is now the consumers outside there. But this one here will be consumed by the interdependent sectors or industries. Therefore, when you say now for X, it gives you the total of 32, which means if you take 8 plus 10 plus 10 plus 4, you will get 32. When you take now 8 plus 10 plus 6 plus 6, you get 40. 8 plus 10 plus 10 plus 2, you get 30. So that is the total. How do we calculate the technical coefficient? It is very simple. This column here will be divided by 32. This column here will be divided by 40. And the last column here will be divided by 30 to obtain what they call technical coefficient. Why? Because this one here will give us the proportion to be consumed inside. Therefore, it means that the probabilities that we should have developed will not be adding up to 1 because we have a portion that is sold to external. If the question is saying technical coefficient, do not bring in this. You only work out the interrelated industries. That is X1, X2, X3, X1, X2, X3. This is not included. Therefore, your work is very simple. You now say 8 divided by 30, 8 divided by 32, 8 divided by 32, 8 divided by 32. You are finished with the first row, first column. Second column, you divide by 40, 10 divided by 40, 20 divided by 40, and 10 divided by 40. The third column, 10 divided by 30, 6 divided by 30, and 10 divided by 30. That is now your technical coefficient. So when you now divide it carefully using your calculator, when you use now your calculator to simplify this, your coefficient here will be 0.25, 0.25, 0.33, 0.25, 0.5, and 0.2, then 0.25, 0.25, and 0.33. So this is now the final answer. So technical coefficient matrix, that is the answer. This gives you 2 marks. We go to the last column. It is saying calculate what? The total what? Output. Total output. How do we get the total output? By use of Leontief model, it says that total output X is given by 1 minus A into brackets minus 1 times what? Times D. Correct? So this one here stands for identity matrix. This identity matrix I've already explained. If it is 3 by 3 matrix like this one, it means identity matrix will be 3. If it is only 2 matrix here, 2 by 2 matrix, this one will be 2 by 2 also. Look at how it is done. You say now 0, you say now the first one, 0, 0, 0, 1, 0, 0, 0, 1. So identity matrix, we said, identity matrix is that matrix where the elements along the main diagonal is 1, while the rest of the elements are 0. So you can see the main diagonal 1, 1, the rest are 0. So that is why they call what? Identity matrix. Then you minus A. What is that A? A is now the Leontief matrix that you have just developed up here. So therefore you minus 0.25, 0.25, 0.33, then 0.25, 0.5, 0.2, then 0.25, 0.25, and 0.33. Like that. So when you subtract, your final answer there will give you, so 1 minus that, you get 0.75. 0 minus 0.25, you get negative 0.25. Another one is also negative 0.33. Then negative 0.25. Then 0.5. Negative 0.2. The last one is 0.25 negative. Then negative 0.25. Final is 0.67. So 1 minus 0.25, you get 0.7. 0 minus 0.25, you get negative 0.2. So this is the first part here. You can see this part here. But then we open now, it's telling you we go to the inverse. How do we calculate the inverse? So we proceed. From here, we get what they call the cofactor matrix template. So this is our matrix now. This is our matrix. Not this one. This is our correct matrix. Now we go now to the coefficient matrix template. So template, it is X. So we now say yes. The first part here will be positive, negative, positive. Negative, positive, negative. Negative, so positive, negative, positive. So therefore, 0.75, negative, negative 0.25, negative 0.33, negative 0.25, 0.5, negative 0.2, negative 0.25, negative 0.25, then 0.67. Convert this one into a template. So positive times positive is positive. So you get 0.75. Negative times negative, according to the template we learned, this one gives you a positive. Then positive times negative, negative. Negative times negative, positive times positive, negative times negative, negative times positive times negative, negative times negative, positive times positive. That's what you are supposed to do. Now, when you do that carefully, your answer you get is 0.25, 0.25, 0 negative, 0.33, 0.25, 0.5, 0.2, negative 0.25, 0.25, and 0.67. So that is your template. This template here, we develop now as many matrices as possible. So let's now develop matrix from this template here. Now, cofactor matrices. Matrices means there are many. So let's now develop. Remember the formula? We said you close the first column, the first row, cancel like that. So we close this and close this, you get this. Then you go to the second, close the first row, close the second column. What is remaining is, you have closed the first row and the second column. What is remaining? 025, 020, 025, and 06 that. So this one is purely now what we discussed that time, matrices. So when you close this one and this one, you have now this. So your first part there, matrix 0.75, 0.25, negative 0.33, 0.25, 0.5, 0.2, negative 0.25, 0.25, and 0.67. So we want now to develop matrices here. So close the first row. Let me just use this. I close like that. I open. Then I close the first row, first column. So I have this. So this one gives me 0.5, 0.2, negative 0.25, then 0. Sorry, that is not the case. 0.25, then 0.67. That is the first matrix. The second matrix, we are still in the first row. Go to the first row, second column. First row, second column. So we have this, 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 and this. So you copy 0.25, 0.2, 0, negative 0.25, negative 0.25, and then positive 0.67. The first column, we are still in the first row. We are closing the first row and this one, so we will have this. So this gives you now 0.25, 0.5, negative 0.25, and 0.25. So we are through the first row. Go to the second row, which is this one now. So you are closing the entire of it. Then you now move from first column, second column to the third column. Correct? So if you go like that, your answer you get for using the second column, the second row will be 0.25, negative 0.33, 0.25, 0.67. Then you get 0.75, negative 0.33, negative 0.25, then 0.67. Like that. Then the last one there for row 2 will be 0.75, 0.25, negative 0.25, and 0.25. So we are through the second row. Third row, which is this one now, You close the entire third row completely. Then you play with the first row, first column. Write what you are seeing because you have already closed this. Write what you are seeing, write what you are seeing, and write what you are seeing once you close like that. So it will give you 0.25, negative 0.33, 0.5, 0.2, then 0.75, negative 0.33, then you have positive 0.25, then 0.2, then the last one is 0.75, 0.25, and finally 0.25 and 0.5. Then you say this is now the matrices that you have developed. When you look at it carefully, it is made up, inside there is made up of 2 by 2 matrix. You can see 2 by 2 matrix. So therefore the normal way of calculating that, you get what? Coefficients. You get now what you call the determinants for each element, for each matrix. That is to say, product of the main diagonal minus product of the minor diagonal. You get the answer there. Correct? So, then you go to the second, main diagonal minus the product of the main diagonal minus the product of the minor diagonal, product of the main diagonal minus product of the minor diagonal, and repeats itself like that to the end. When you do that using your calculator, your answer you get by saying the main diagonal, product of the main diagonal minus product of the minor diagonal. For all these, your answer you get there is 0.335 minus 0.05 for the first one. You go here, the second is giving you 0.1675 minus 0.05. The last one there is 0.0625 minus 0.125. Then the second row will give you 0.1675 minus 0.0825, then 0.5025 minus 0.0825, and the last one is 0.1875 minus 0.0625. And the last one there is 0.05 minus 0.0165, then 0.15 minus 0.0825, then the last one is 0.375 minus 0.0625. You can see that. So this is now your matrix. We are just doing continuation of what we have done up there. So you have now found the determinants of each of the 2 by 2 matrix that you have developed here. Now, I want you to look at what is happening. Minus minus will give you positive. Therefore, it means I'm adding here. This is minus minus, it means it will give me what? Positive. Where else can you see minus minus? I can see here. Where are you seeing another minus minus? It is also here. Where else can you see minus minus? It is here. Where else do you see minus minus? I can see it is here. Now, if you now work out exactly what is inside there, your final answer will be 0.335 0.285, 0.1175, and 0.1875, 0.25, 0.42, and 0.25. The final is 0.215, 0.2325, and finally 0.3125. So therefore, our correct cofactor matrix, this is the final part of it. Once you have now our simple matrix here, we go to the second stage of determining this, that is called what? Now look at what is happening now. Now we have this. The second step after we have calculated our cofactor matrix is to get the determinant. How do we get the determinant? Where do you get? I told you last time that for you to get the determinant here, you go to where your main matrix was before affecting it. Correct? So before affecting the matrix, this is now your matrix. This is now your first part of it. And then the last one that you have now is this one here. So therefore, you take the first part, 0.75 times 0.285 plus negative 0.25 times 0.1175 plus negative 0.33 times 0.1875. Don't go, you go exactly where you have said identity minus coefficient matrix. So when you say identity minus coefficient matrix, you get this one. So this one here is your matrix without template, without the template. So you take the first row, multiply by the first row in the coefficient matrices. So your answer is very simple. So once you have known that, you come now and say yes, it is 0.75 times 0.285 plus into brackets negative 0.25 times 0.1175 plus negative 0.33 times 0.1875. So your final answer, when you work out using your calculator, your answer you get is 0.1225. So that is your determinant. From where? How do you get the determinant? You go to your main matrix where you said identity minus coefficient matrix. Then you identify the first row. Then we have also the first row here. So you multiply, you get that answer. Once you are through now, what do? You get the inverse. So therefore the inverse, how do you get the inverse? It is 1 over 0.1225 into, take note of what I'm doing. The inverse. What is the inverse of this matrix? So we are taking the inverse of the determinant. You multiply by the inverse of the matrix, which is this one. How do you get the inverse? We borrow what we call transpose. Transpose says what? Interchange the columns with the rows, or the rows with the columns. So this row here becomes the first column. The second row here becomes the second column. And the third row becomes the third row, the third column, as simple as you can see. First row, first column. So it will give you, if we interchange now this one like this, it will give you now the answer as 0.285, 0.1175, then you get 0.1875, then the other one is 0.25, 0.42, and 0.25. Then 0.215, 0.2325, then finally 0.3125. So what is that now? Sorry. So what is that? This is now the inverse. Then you can work out how do we solve it now. You are saying you take now the inverse that you have, you multiply by the answer. So you are told they are equals to what? From the question, you are told they are, let's go to the question. The question was saying, if the final demand for the output of industry X1, X2, and X3 becomes 6, 4, and 6. 4 and 6. Meaning the final, you see, when you look at the table there is showing 4, 6, 2. So you are being told that the final demand is now affected, it is changing. Therefore, instead of 4, it is 6. Instead of 6, there it is 4. Then instead of 2, there it is 6. So therefore, out of this Leontief matrix, you multiply by the changes that have actually occurred in the final demand. So in this case, the final demand has changed to 6, 4, and 6. Then get the answer. Very simple. Row times column. You get the answer. Second row times column. You get the answer. Third row times column. How do you go about? 0.285 times 6 plus 0.25 times 4 plus 0.215 times 6. You get the answer. Then 0.1175 times 6 plus 0.42 times 4 plus 0.2325 times 6. You get the answer. And then also applies to the final. So when you now use your calculator very well, your answer there you get is 1 over 0.1225 into, if you multiply the way I've done here, I've explained there, your answer you get is 4. First part here is 4, 3.78 and 4. So if you open now the brackets, 1 over 0.125 times 4, you get the answer. 1 over 0.125 times 3.7. Where is this one coming from? The second column, the second row, sorry, this one. 0.1175 times 6 plus 0.42 times 4 plus 0.2, that you get this one. Then when you open that brackets, your answer you get there is equals to 32.65. Then 30.86. And the last one is 32.65. So this one here represents what? X1, and this one here represents X2, and this one represents X3. So that is how you are supposed to solve that example 1. So you can see how simple a question was, but it consumes a lot of time. This one, remember, it carries 10 marks. 10 marks. So our steps are very important. Very, very, very important. So let's see example 2. So let me explain example 2. Then from there, you can do the rest. Example 2 says, an economy consists of 3 industries, R, S, and T. The relationship between the production of these industries is as shown below. Units in thousands tons. Then we have this table here. We have R here. We have S and T. Then we have consumer. Then we have the total. So we have 50, 20, 30. Then we have 20, 30, and 20. Then T, we have 40, 20, and 20. Final consumer, 70, 90, and 50. then total 180, 160 and 120. Then we have here from R, S and T. I want to explain first, where is our interdependent sectors? This one here. From here is where we have our coefficient what? Matrix. 2, this consumer behavior which is sold to outside external market will be keeping on changing. So when you look at this question, they are saying what happened? Roman 2. If the final demand for the outputs of industries, what is that one? If the demand is expected to change for R, S and T, and it becomes the final demand, the demand here, which is the customer in this case. So customer is the final demand. From the previous question, it was a final demand. Here they are saying consumer. So they mean final demand. So it is changing. Instead of 60, instead of 70, it is now 60. Instead of 190, it is 110. It is instead of 50, it is 60. You can see. So this one here is now when we shall be now saying total demand. But before we go there, let's calculate the coefficient. Roman 1 is saying determine the input-output matrix. Roman 1. Input-output matrix. How do you get it? So we have said the first row, the first column, divide by the first row there. The second column, second row. The third column, divide by this one for you to get this. So therefore, if you work out this, if you divide this question carefully, you will get 0.28, 0.13, if you round off, 0.33, 0.11, 0.19 and 0.17, then finally 0.17, 0.13 and 0.17. That is a first. So you just say 50, all this divide by 180, this one, the whole of this divide by 1. Then the last, the last part say total output, which you write your formula carefully by saying total output is X equals to A1 minus A. This one stands for the inverse, then multiply by demand. So this demand here will not be 70, 90 and 50. It will be what? The demand has changed to 60, 110 and 160 from the question. So therefore, you will put it here. Before you reach here, you calculate this part here, which is identity 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. Then say minus 0.28, 0.13, 0.33, 0.11, 0.19 and 0.17. Finally 0.17, 0.13 and 0.17. Like that. Then your final answer there will give you how much? If you subtract carefully, if you work out that subtraction, you will get 0.78, negative 0.13, negative 0.33. The other one is negative 0.11, positive 0.81, and finally negative 0.17. Then the other one is negative 0.17, negative 0.13, and positive 0.83. So that is your, this is our main matrix. When we are going now to determine the determinant, we will come here, because this is now our original matrix, this one. Then the next step after we have done this one is to develop what we call coefficient what? Coefficient matrix template. How do you get the template? Positive times positive, positive. Negative times negative, So you go and develop the template, which is now positive, minus, positive, negative, minus, sorry, plus, minus, positive. So this is a template. So can you get the template now here? Positive times positive, negative times negative, positive. Positive times positive, negative, sorry, negative. Then negative times negative will give you positive. Now the interchange here, if you work out now this one, it will give you the answers as 0.78, positive 0.13, and negative 0.33. That is the first row. The second row should give you 0.11, 0.81, and finally 0.17. Then the third one should give you negative 0.17, positive 0.13, and positive 0.83. So when you open your template, when you open now this one, it will give you this template here. Once you have this one now, you develop what you call coefficient matrices, which we have already said that coefficient matrices, your work will be very simple. So first, you close the entire first row, row like that. Then you play now with the second column, first column like that. Write the figures you are seeing. Second, figures you are seeing. That's one like that. Then the second one, you close the entire second row. Then you play with the first column, second column, third column. Then the last one is close the entire third row. Then you play with the first column, second column, third column. Simple like that. Then once you do that, your answers you get are 0.81, 0.75, that one, 0.13, and 0.83. That is the first. Second, you get 0.11, 0.17, negative 0.17. Then you get 0.83. Then the last one is 0.11, 0.81, negative 0.17, and 0.13. Correct? Then you obtain the other one will give you 0.13, negative 0.33, and 0.83. The other one will give you 0.78, negative 0.33, then negative 0.17, then 0.83. Then the last one will give you 0.78, 0.13, negative 0.13, negative 17, then 0.13. Then the last one will give you 0.13, negative 0.33, 0.81, 0.17. Then we have 0.78, negative 0.33, 0.11, and 0.17. Then the last one is 0.78, 0.13, then 0.11, finally 0.81. Then this one is like that. Then you bring down now. You can see it is now 2 by 2 matrix, the simplest. Then get the determinant using the 2 by 2 matrix. Product of the main diagonal minus product of the minor diagonal. Then you proceed like that for the rest. So if you worked out that, you will get 0.6723 minus 0.0221. This one is 0.0 913 minus 0.0289. Then the last one will give you 0.014 0.0143 minus 0.1377. Then the second part of it will give you 0.1079 minus 0.0429, then 0.6474 minus 0.0561. Then the last part is 0.1014 minus 0.0221. Then the last part is 0.0221 minus 0.022673. The last part is 0.1326 minus 0.0363. Then the last one is 0.6318 minus 0.0143. Now once you have this one, check where you have the minus minus, you put it positive. Here, positive, which means you are adding that. You are also adding this. You are also adding here. You are also adding here. And you are also adding here. Then when you work out that, your final answer there should give you 0.6502, 0.1202, 0.152. Then we have 0.1508. Then we have 0.5913. Then we have 0.1235. Then we have 0.2894. Then we have 0.1689. Finally 0.6175. So that is your final matrix from coefficient matrix. This is your answer now. How do you get the determinant? After this, you immediately get the determinant. Where is your determinant? I told you go back to the original matrix. Where is your original matrix? It is here. So we pick the first row, multiply by the first row also here. So by saying 0.78 times 0.6502, you get the answer. Negative 0.13 times 0.1202, you get the answer. You add. So your answer now will be 0.78 times 0.6502 plus negative 0.13 times 0.1202, you plus into brackets negative 0.33 times 0.152. So your answer there will give you 0.4417. Correct? Once you get now the determinant, you go to the inverse. So the inverse now will be 1 over 0.4417 into inverse. How do you get the inverse here? Row becomes the first column, second row the second column, and the third row becomes last column. So your work will be very simple. So interchange, this one will give you 0.6502. This one gives you 0.1202, then 0.152. The second row becomes 0.1508, 0.5913, then 0.1235. Then the last row, 0.2894, then 0.1689, then 0.6175. So that is the inverse. How do you get the answer? You multiply by the demand. In this case, we are not going to use the 70. We go back to the question. The question was saying it was changed to 60, 110, and 110. So you multiply by 60, 110, 60. So if you multiply this one carefully as the way we have done, your answers you get will be 160 equals to 165.3. Then you get 186.67. Then you get 135.39. So this one will be R, S, and T. That is how you are supposed to work out on that particular question. Therefore, I give you some more work. Do example 3, 4, and 5. Then share to me via WhatsApp. I will be able to work and direct on the same. So thank you so much and have a good day ahead.